Good morning, my dear students. So today class continue the exercise problems, how to solve step by step. So let us see the exercise problems. Exercise 5.1. It is very important topic, so very well. So last class I explained how to solve the problem. So let us see the questions. Exercise 5.1. Okay. So the first question is like this. Prove that, question asking like this. Prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 3, at x is equal to 0, at x is equal to minus 3, and at x is equal to 5. So this is the problem. Okay, to show that continuous, we know the concept of continuous meaning. So draw the graph of the function without lifting pen. So without break. So whenever there is a given conditions, we have to find left hand limit and right hand limit and f of a. So if they all are equal, we have to say that it is a continuous. Left hand limit, right hand limit, and f of x at x equal to a. If all three are equal, then it is continuous. One of them not exist also, it is discontinuous. So last class we have given definition. We know the definition studied. Wherever there is no conditions, here there is no conditions. So directly we have to prove that in this case, limit of f of x as x approaches to a equal to f of a. So both are giving same meaning. If there are conditions there, we should follow this method. Or else here also we follow same method, answer we are getting. Okay, now how do I solve simple questions? These are the 3 marks questions, 5 marks questions are there. To solve this one, at what points we have to check? At x is equal to 0, that is first one. Second one is at x is equal to minus 3. So totally there are 3 questions are given. Okay, firstly I have to take given function every time. Given f of x equals 5x minus 3. The first bit I would have checked at x is equal to 0. At x is equal to 0, I would have find f of 0. f of 0 is equal to, it means fill the condition here. So put x is equal to 0. So allow x replacing by 0 over here. f of 0 equals 5 into 0 minus 3. This equals 0 minus 3 equals minus 3. Okay, and also now also. Now limit of f of x as x approaches to 0. Limit of f of x as x approaches to 0. This is equal to limit of, what is the f of x? 5x minus 3. Here we don't have any breaking conditions. We do not have break conditions, so directly I will have explained. As x approaches to 0. This is equal to, now I apply the limit directly. So we know the limits concept. So replacing x is equal to full. So fill x equal to 0. 5 into 0 minus 3 is equal to 0 minus 3 is equal to minus 3. We observe what? So limit of a function is equal to f of 0. Therefore, limit of f of x as x approaches to 3 will be f of 3 is equal to minus 3. Hence, f is continuous. F is continuous at x is equal to, here x approaches to 0, no? Continuous at x is equal to 0. So here we got f of 0. This is, okay, don't do the mistakes. F is continuous at x is equal to 0. Without doing this method, we can say, what do you call this is? It is a polynomial of a function, linear function. So every polynomial function is continuous everywhere. Polynomial function is continuous everywhere. So it is a continuous function. This is the first bit in this problem. The first bit is what? At x equal to 0. Same procedure we have to apply. Next bit is at x equal to minus 3. Second problem, at x is equal to minus 3. X is equal to minus 3. F of, firstly, we have to follow similar, exactly similar. F of minus 3 will be, substitute x is equal to minus 3. That is 5 into minus 3 equals minus 15 minus 3 equals minus 18. This is f of minus 3. Now we have to find limit. Now limit of f of x as x approaches to minus 3. This equals limit of f of x is, function is 5x minus 3 as x approaches to minus 3. Now you apply the limit. This is equal to 5 into minus 3 minus 3. This will be minus 15 minus 3, that equals minus 18. So I said now clearly, our observation is always correct. Every polynomial function is continuous for all real numbers. So here also it is true, limit is equal to f of So we can write hence f is continuous at x is equal to -3. This is the second bit. X equal to 0 definition, x is equal to -3 is definition. In the same manner, exactly similar, prove that at x equal to 5. Okay? So at x is equal to 5 is the third one. So I will go here at x is equal to 5. This is the third bit. In this problem, third one, this is only. Firstly, we have to calculate f of 5. That equals function, we know that. Substitute x is equal to 5. 5 into 5 minus 3. This is equal to 25 minus 3. This will be 22. Okay. Now next one is the finding. Limit we have to find. Limit of f of x as x approaches to 5. At 5 we have to calculate. This equals limit of f of x is what? 5x minus 3 as x approaches to 5. Now we have to apply the limit. It means what? Fill x is equal to 5. That is 5 into 5 minus 3. 25 minus 3 is equal to 22. Observing this is nothing but what? f of 5. Therefore, limit of f of x as x approaches to 5 is equal to f of 5. This will be 22. Hence, f is continuous. F is continuous function at x is equal to 5. Like we have to do it if there is no breaking conditions. If no breaking conditions, you should apply direct limit problems. We can easily show the answer of these questions. Okay? Like we can show that all time of the total exercise we are doing like this only. Clear? We will see more questions. Let us take the question number 2. Okay? Understood this problem? Prove that the function f of x is continuous at x is equal to 5. At x is equal to 5, at x equal to 0, at x equal to minus 3. Now I will go second problem. Shall I move? Okay, take the problem number 2. In the same exercise, there are nearly given 20 to 30 questions are there. Okay, model, only one model this is. In this model, sometimes show that continuous, sometimes show that find the, if it is a continuous, find the value of k. So find the value of k model, repeated question for example. These are also important. Okay, now I will go through the question number 2. And on the problem is examining the continuity of the function. The continuity of the function. Simple given of the function f of x is equal to 2x square minus 1 at is equal to 3. So this is almost exactly similar problem. So we should examine that whether it is a continuous or not and x is equal to 3. And do we have breaking conditions? We do not have breaking conditions, means we should do directly. Some of the people they are doing here with breaking conditions also. It is also correct, but in this case we don't want like this. We can say very easy, observing all of you, 2x square minus 1, what do you call? It is a polynomial function, quadratic function this is. Hence it is a continuous everywhere. Check once again. Let us see we solve the problem. As it is in the same model, I would have take the function given f of x is equal to 2x square minus 1. We have to check at, this is the limiting point only. So at what points we have to check important. He will mention in the problem. In case not mentioned means we should take general. At x is equal to 3. At x is equal to 3. Firstly we have to determine, find the value of f of 3. So f of 3 is equal to 2 into 2 whole square minus 1. This is 2 into, that is 2 square value 4. 4 to the 8. 8 minus 1 is equal to 7. We got it. Now we have to find a limit function. Limit of f of x as x approaches to 3. We don't have conditions here. If there is a conditions, inequality conditions are there or modulus there, we should break into cases. This equals limit of f of x. What is the f of x? This is only 2x square minus 1 as x approaches to 3. This will be, substitute x is equal to 3. Something is done here. Okay, 2 into 3 square this is. 2 into 3 square value, 3 to 0. Observe that 9 to the 18. 18 minus 1, that is 17 here. Clear? Mistake. Sorry. 2 into 3 square minus 1, that is 9 to the 18 minus 1, 17. Now here also apply the limits. 2 into 3 square minus 1. This is equal to 18 minus 1. This equals 17. Clear? Yes, very simple. Therefore, limit of f of x as x approaches to 3. This is equal to f of 3. Correct? How much we got? This number is 17. So we just examine this. Therefore, f is continuous. F is continuous at x is equal to 3. It is enough. Okay, we should examine like this. Whenever there is no breaking two conditions. Breaking condition, no breaking conditions, we should directly do it. Clear? Shall we go next problem? Problem number 3. See the third question. There are nearly 4 questions are given. Third question is examine the following functions. The following functions for continuity. For continuity. So it means same as it is. We have to check whether the given functions are continuous or not. There he has given problem number A. F of x is equal to x minus 5. Second problem, f of x is equal to 1 upon x minus 5, where x does not equal to 5. Third way, f of x is equal to x square minus 25 upon x plus 5, where x does not equal to minus 5. And fourth way, f of x is equal to mod of x minus 5. Okay? Now we have to find continuity or not. How do we check? Do we have to check at any point or at the particular points? So in this problem there is no particular point. You should take any real number. Any real number. So real number is always constant. So how to examine this is, let us see one or two questions. Okay, now I am taking first problem. So what is the given value? Given f of x is equal to x minus 5. I said very clearly, without checking also we can say how it is a polynomial function. Every polynomial function is continuous at every real number. For all real numbers, everywhere. So I need to check it is a continuous or not using this method methodically. Let us take a real number, that is x is equal to, I am taking any real number a. It is a real number, any real number. I consider only x value. I would have checked at real number a, because he has not given any number. In this case, I have to find out f of a. F of a. F of a is equal to what? Replacing x by a minus 5. It is a constant. A minus 5. And also find limit value. Now limit of f of x as x approaches to a here. This equals limit of, what is the f of x? F of x is x minus 5 as x approaches to a. Apply the limit. This is equal to a minus 5. Okay? Observing, this is nothing but what? F of a. Is it? Yes, it is exactly f of a. Therefore, limit x tends to a, f of x is equal to f of a, that is a minus 5. Hence, f is continuous. F is continuous everywhere. F is continuous everywhere, no. So, A is a real number. F is continuous everywhere. It is continuous everywhere. For all numbers, for all real numbers, it is a continuous. You take any numbers. Instead of checking all real numbers, I would have taken a real number A. Correct? In the same manner, applicable in the remaining 3 questions also. You want? Let us see now question number 2. I will examine the second problem. So what is the f of x value? Here f of x is equal to 1 divided by x minus 5, where x naught is equal to 5, except 5, except 5 here. We have to check any real number except 5. Already he present the condition. He has given the problem. Condition has given. So let us take, let a is equal to, at x is equal to a, any real number which is not is equal to 5, belongs to real number. Any real number I take here. A does not equal to 5. The remaining all numbers should be taken here. So what is the f of a value? F of a is equal to 1 upon a minus 5. Okay. Now limit check here. What is the limit of f of x as x approaches to a? This is equal to limit of 1 upon x minus 5 as x approaches to a. This is equal to 1 divided by a minus 5. Observing, we observe what? Aren't they equal? Yes. Therefore, limit of f of x as x approaches to a is equal to 1 upon a minus 5. This is equal to f of a. Hence, f is continuous and f is continuous everywhere. F is continuous everywhere except x is equal to 5. Except x is equal to 5, it is continuous. This is the second problem. It is clear? Very simple method. So mathematically we should do it, answers are getting. Now we are going to third bit. What is the third question here? F of x is equal to, third one, f of x is equal to x square minus 25 upon x plus 5. Here also x does not equal to minus 5. So let us see third bit answer. So I would have a given function. Given f of x is equal to x square minus 25 upon x plus 5, where x does not equal to minus 5. Now here I consider, suppose x is equal to any constant. You can take k or c, whatever the a, as your wish this is. Take the constant, but this must be not equal to minus 5. X does not equal to minus 5, which is a constant, real number. Any real number this is. It is a polynomial function, hence we can simply show that. At this function, we have to find f of c firstly. F of c is equal to c square, fill x equal to, so replacing x by c everywhere. In the function, fill x is equal to 5. C square minus 25 upon C plus 5. You know very well there is a one formula A square minus B square. 25 I can write 5 square. Okay, A square minus B square formula applying, we get C square minus 5 square divided by C plus 5. This is equal to C plus 5 into C minus 5 divided by C plus 5. Now I have cancelled like terms. This is equal to C minus 5. This is the value of f of C. Now I will have find limit of a function. Now limit of f of x as x approaches to C. This is equal to limit of what is the f of x? X square minus 25 upon x plus 5 as x approaches to C. This equals limit of, I can write using formula x plus 5 into x minus 5 divided by x plus 5 as x tends to C. Now simplify. So this is get cancelled. Limit of x minus 5 as x tends to C. Now apply the limit. Put x is equal to C. We get C minus 5. So observe what? Do you get equal numbers? Yes, we got x equal to C minus 5. Therefore, limit of f of x as x tends to C is equal to f of C, that is equal to C minus 5. Hence f is continuous. F is continuous at x is equal to C. That means everywhere it is continuous. F is continuous everywhere, but there is except x does not equal to minus 5. Except x does not equal, except x equal to 5 minus 5. Except x is equal to minus 5. Reminding that all real numbers, it is a continuous function. Except minus 5, it is a continuous everywhere. Okay, yeah, whatever you do it, questions are doing like this only. Shall we take the problem? So what is our problem number D after that? See the problem number D. So mod x problem this is. Given f of x value, same procedure. Throughout in this chapter only one method. So finding this is, if there is a breaking conditions, we have to find upper limit, lower limit, that is left hand limit, right hand limit and f of a. Mod of x minus a. Here conditions are there. So observe that what are the conditions. I only have breaking two cases. This is mod x model. So mod of x minus 5 value minus of x minus 5 value when x is less than 5. Okay, when x is smaller than 5, this function always becomes negative. Okay, we know the mod x property. Mod of x is equal to minus x when x is less than 0 plus x when x is more than or equal to 0. As according to this, I break the conditions. Mod of x minus 5 is negative when x is less than 5 plus x minus 5 when x is more than or equal to 5. Actually, this is the question. When x is less than smaller than 5, what is the function? Minus of x minus 5. So we get left side this is. When x is more than or equal to 5, that is positive value. Okay, this is the break into conditions. So we have to break into conditions with the help of mod property. Now we have to check that x is equal to 5. Clearly there is a limit. At x is equal to 5, we have to examine whether it is a continuous or not a continuous. So now in this case, we should find out left hand limit, right hand limit and f of a. So firstly I have to find f of a. F of a is f of 5 is equal to. So when x is equal to 5, what are the conditions? This is only applied. When x is equal to 5, f of x is equal to what? X minus 5. When x is more than 5, what is the f of x? X minus 5. When x is smaller than 5, what is the f of x value? Minus of x minus 5. Okay? Minus of x minus 5. So, according to conditions, we should find out answer of this. F of 5 is equal to 5 minus 5. This will be 0. I completed f of a. Now I have to find limit functions, that is the left hand limit. First one is left hand limit. Left hand limit concept, limit of f of x as x approaches to 5 minus. It represents left hand limit from left side as x approaches to 5 from the left hand side, from left side. So I represent left hand limit like this: a minus, 5 minus, 3 minus, 4 minus, like this. That is what smaller than 5 mean. Function, if x is smaller than 5, what is the f of x value? This is a minus of x minus 5. So limit minus of x minus 5 as x approaches to 5 minus. Okay? Or else we can do one more method easy instead of this. Yesterday given earlier. So this is change the limits also. So this can be also written as using limits. Limit h tends to 0. This is very beautiful method. Very nice method this is. As x approaches to 5 minus, h tends to 0. As x tends to 5, f of x changes f of 5 minus h. Okay, x minus a minus h. Okay, as h tends to 0, this becomes f of 5 minus h. X value becomes 5 minus h only. As h tends to 0, I will show clearly here. X tends to 5. Okay, na? This meaning 5 taking this side. X minus 5 tends to 0. I consider this is h. H tends to 0. Okay, that is x minus 5 is equal to h, meaning x is equal to what? Okay, that is h plus 5. If you take minus 5 minus h, if you take plus 5 plus h. So 5 minus h meaning what? It is smaller than 5, clearly. So this is the limit concept. Smaller than 5 meaning. So same meaning. 5 minus means smaller than 5. This is also smaller than 5. So smaller than 5, what is the function? This is only. So this is equal to limit as h tends to 0. Okay. So this is f of x value. So fill x is equal to 5 minus h here. Minus already there. Minus of 5 minus h. Okay. Minus of 5 minus h, already minus 5. Now we simplify. Plus 5 minus 5 cancel. This is equal to, observe that, limit of minus plus h as h tends to 0. Apply the limit, this becomes 0. Clear? In the same manner, right hand limit also find out. Right hand limit. Let us see right hand limit value. So or HL. How to I write this one? Limit of f of x as x approaches to 5 plus. As x approaches to 5 plus this is more than 5 meaning right hand limit. I can change this one. How do I write this one? This also is equal to limit of f of 5 plus h. 5 plus meaning more than. So 5 plus h as h tends to 0. What is the h here? This is very small quantity, negligible value. But it always lies between 0 and 1. It doesn't less than more than 0. Between 0 and 1 only, 0.1, 0.2, 0.000, 1.05, 0.002. A small quantity. It is a very small quantity increment value. If you add h value, it is more than 5. If you subtract h value, it is less than 5. Less than 5 this is more than 5. If more than 5, what is the f of x value? More than 5, x is more than 5, what is the f of x? X minus 5. So here x is equal to 5 plus h substitute here. This equals limit of x is what? 5 plus h minus 5. Okay, this is more than 5 condition as h tends to 0. Now plus 5 minus 5 cancel. Limit of h as h tends to 0. This is equal to 0. Now we got left hand limit is equal to 0. Right hand limit is equal to 0. F of 5 also 0. So we observe what? Therefore, left hand limit is equal to right hand limit is equal f of 5 that is equal to 0. Hence, f is continuous. F is continuous at x is equal to 5. Okay? F is continuous at x is equal to 5. Whenever there is a modulus functions, inequality conditions, first we break into cases. After the breaking cases, we do this method. Throughout in the chapter, we are doing this method maximum. More than, less than, equality. Okay? Examining only these conditions. If it is true, it is a continuous. One of them not equal, hence it is not a continuous. Like we are doing the problems every time. Clear? Let us see one more problem. I would have explained. Take the question number 4. Fourth question. Prove that the function f of x is equal to x raised to n is continuous at x is equal to n, where n is a positive integer. Where n is a positive integer. So here, can you say without solving this problem? Yes. How do you say that? It is what? X raised to n is what? A polynomial function. Polynomial function everywhere continuous. Everywhere continuous. Polynomial is function continuous everywhere. So for sake of understanding, we have to do this answer very simple way. Same as is above, similar. Given f of x is equal to x raised to n. At what point we have to check examine the continuity? At x is equal to n. At x is equal to n. So find f of n, that is equal to n raised to n. It is a constant. Now limit to find out. Limit of f of x as x approaches to n, because we do not have any breaking conditions. Here we break into conditions, no? So I find the left hand limit, the right hand limit, finally we proved answer. This equals limit of x raised to n as x approaches to n. This is equal to apply the limit n raised to n. Therefore, limit of f of x as x raised to n is equal to f of n. Therefore, f is continuous at x is equal to n. So if there is no breaking conditions, you should do it normal method. If there are breaking conditions, we should apply left hand limit, right hand limit, finally show that answer like this. Is it clear? Shall I give the fifth question? So problem number 5. So all conditions are like this, only we prove that every problem. So this is the method only. Methodically we can show that each and every question in continuity problems. Okay, but if you are doing more questions, you get perfection also in every problem. But only there is changing function. They change only functions here. Very easy to solve all type of questions in the continuity. Once again, let us see the question number 5. What is the fifth question? See here. Is the function f defined by f of x is equal to, say the breaking condition is x if x is smaller than or equal to 1, 5 if x is more than 1, continuous at x is equal to 0. First question. At x is equal to 1. Second problem. At x is equal to 2. Third problem. Okay. This is the problem of fifth one. So we have to examine at x equal to 0, at x is equal to 1, at x is equal to 2. Okay, in all three cases we have to show that we should examine is it a continuous or not. When x is smaller than or equal to 1, f of x is x. When x is more than 1, that is 5. So here 0, is it a smaller than 1? Smaller than 1? Yes. At x equal to it is only, everywhere it is the same function. Okay. So let us see. We prove this problem very easily. So what is the given function? Given f of x is equal to breaking conditions x if x is smaller than or equal to 1, 5 if x is more than 1. Now the first bit where we have to examine at what point? At x is equal to 0. At 0 we do not have any breaking conditions. We have only one condition, that is x. Okay, at x is equal to 0, function is what? X only. So we have to find f of 0, that is 0. Now find the limit of this function. Limit of f of x as x approaches to 0. This is equal to limit of f of x as x approaches to 0. X approaches to 0, which is what here? Smaller than 1. It is a smaller than 1. Function is what? X. So apply the limit, we get 0. So therefore limit is equal to 0. Therefore limit of f of x as x approaches to 0 equal to f of 0, this is 0. F is continuous, it is clear. F is continuous at x equal to 0. So this is more than 0 is exactly either 0 or more than this break conditions. So we do not have any breaking conditions at x equal to 0. Only one condition, f of x is equal to x only function. He defined this is. He defines every concept like this. Now at x is equal to 1, at x equal to 1, he has broken two conditions. What is the first one? Smaller than 1 and more than 1. So we should find out here all values. Now the second bit, at x is equal to 1. At x is equal to 1, find the f of 1. When x is equal to 1, exactly 1. What is the f of x value? X. Exactly 1 is f of x is what? X is there. Substitute here x is equal to 1. That fill x equal to 1. That becomes f of 1 is equal to 1. Clear? F of 1 is equal to 1 here. Now we have to find left hand limit. LHL, that is the limit of f of x as x approaches to 1 minus. Left hand limit. 1 minus less than, smaller than 1. Can we change in other form? Another way, we can write this value. Limit of f of, simply what I do? So x subtract from 1, that is h, 1 minus h. Limit of f of 1 minus h as h tends to 0. So the confusion is removed here. It is very beautiful. If you observe that 1 minus h, is it smaller than 1? H is what? A small quantity. It is a small interval only, small quantity. If you subtract small interval from 1, is it smaller than 1? Yes. If smaller than 1, if x is smaller than 1, what is the f of x value? X. This equals limit of 1 minus h, that is x replacing by 1 minus h as h tends to 0. Now we apply the limit 1 minus h is what? 0 is equal to 1. Okay, this is the left hand limit. Then right hand limit condition or HL. Limit of f of x as x tends to more than 1 means I will represent 1 plus. I will show like this. 1 plus represents more than 1. Now I can change this value. Also I can write same number. Limit of f of, how to write this one? 1 plus h. This is 1 minus h. 1 plus h meaning what? More than 1. 1 plus h as h tends to 0. This is equal to limit of h tends to 0 more than 1. What is the function? More than 1. If x is more than 1, f of x is what? 5. So this is 5 only. Now this becomes what? Limit of a constant is a constant, 5. Now you observe that here we are observing left hand limit not equal to right hand limit, correct? So what happened here? Therefore, limit of simply we can write LHL. This is equal to what? F of 1. Okay, it is satisfied, but not satisfying right hand limit. So one of them, left hand limit not equal to right hand limit. Is it a continuous? No. Therefore, F is not continuous. Not continuous at x is equal to 1. Not continuous meaning discontinuous at x is equal to 1. Clear this procedure? It is the main method. Methodically you do it always. And one more thing, at x is equal to 2. So that is the third bit. Third bit at x is equal to 2. At x is equal to 2, how do we do this answer? 2 is what? More than 2. More than 2, what is the function only defines? Only one value. So f of 2 is equal to 5. More than 2, that is, more than 1 is only one f of x as x approaches to 2 is equal to 5 is equal to f of 2, that is 5. Hence f is continuous at x is equal to 2. F is continuous at x is equal to 2. So in the given values at x equal to 0 it is continuous, at x is equal to 1 it is discontinuous, at x is equal to 2 it is continuous. Clear? So like we are doing all exercise problems, remaining questions we do like this. We will see the one more class, same explanation is there in every way. We do it different functions there. All different type of questions are there, we can do it like this. Clear?